Hello everyone, welcome to my channel. In my previous video, you have already known that how to concentrate the ores. So now the question is what to do with that concentrated ore. So the next process is extraction of the crude metals from the concentrated ores. So the first step of this one is conversion of the ore into its metal oxides, and next one is conversion of the metal oxides into metal. Okay. So today we will discuss about this one, that means conversion of the ore into metal oxides. So this process follows calcination and roasting. Now the question is what is calcination and what is roasting? One by one we will discuss about this. So at first calcination. So calcination is the process of conversion of an ore into its oxide by heating it strongly below its melting point in absence or in limited supply of air. That means calcination means in absence or limited supply of air we heat the ores. Okay, so next question is which kind of ore can undergo calcination? One is metal carbonates, they can undergo calcination. Next one is metal hydrides, they can also undergo calcination. So here I have written many examples of calcination. For example, this is what? This is bauxite, right? So from bauxites we can get alumina, that means oxide of the ore. So Al2O3 2H2O upon heating produces alumina along with water. As the medium is heated, it will be evaporated. Next one is limonite. Limonite upon heating produces ferric oxide along with water. Okay. Next one is calcium carbonate. As I have told you that metal carbonates can also undergo calcination procedure. So calcium carbonate upon heating produces calcium oxide along with carbon dioxide. Next is dolomite, that means CaCO3, MgCO3 upon heating produces two metal oxides like calcium oxide and magnesium oxide along with carbon dioxide. So after heating it produces the metal oxides, right? And some impurities are also present in ore which are removed as their volatile oxides, and removal of the moisture, that means the moisture is removed, you can see, and gaseous substance makes the ore porous during calcination, and so the reduction is easier in the next step. Okay, so this is all about calcination. So next is roasting. As I have told you that calcination occurs in absence or in limited supply of air. Roasting occurs in presence of excess air. This is the difference between calcination and roasting. Now the question is which kind of ore can undergo roasting? Normally sulfide ores undergo roasting. Okay. So this is the process of conversion of an ore into metal oxides by heating strongly in presence of excess of air at a temperature below its melting point. So this one is roasting. Both calcination and roasting produces the oxides of the metal, but this is the difference. That means it occurs in absence or limited supply of air, but it occurs in presence of excess air, and it involves metal carbonates and hydroxides for the calcination procedure, whereas roasting involves sulfide ores. So these are the differences between calcination and roasting. Now many impurities are present in the ore, so how to remove them? Like sulfur, phosphorus, arsenic, they are present in the ore. So as this process is performed in presence of excess air, so what will happen? These impurities, that means sulfur, phosphorus, arsenic, they will be converted to their corresponding oxides. Like sulfur will be converted to sulfur dioxide, arsenic will be converted to arsenic oxide, and phosphorus will be converted to phosphorus pentoxide. Okay, so all these are gaseous, and moisture is removed from the ore and the non-metallic impurities like this sulfur, phosphorus, arsenic, they are removed as their volatile oxides. Now the sulfide ores, like this is copper glans, Cu2S. In presence of oxygen, if this is heated, then it produces cuprous oxide. Why cuprous? Because oxide is 2 minus and here 2 copper atoms are there, so +1 each, so this is cuprous oxide along with sulfur dioxide, and sulfur dioxide will be removed. Zinc sulfide also produces zinc oxide by this procedure, and we will have zinc oxide along with liberation of sulfur dioxide gas, and the ore becomes porous and thus makes the subsequent process, that means the reduction process in the next step, easier. Okay, so both calcination and roasting are usually carried out in reverberatory furnace. Okay, so I think now the concept of calcination and roasting is clear to you everyone. Next one is conversion of the metal oxides into the metal. So in my next video, I will be talking about conversion of the metal oxides into metal. If you are new to my channel, then subscribe, and of course do not forget to hit the bell icon to get notification whenever I post a new video. Thank you everyone.